Boy, I'm excited. For one of the rare times in my adventures in real analysis, I'm actually jazzed up on the topic. And so, despite the fact that it's 3:15 a.m. and I gotta whisper because I'm gonna wake people up, I had to make this video. Because usually I just don't want to make a video about real analysis because it's just not that fun. So, going through this book, I want to just give over like the mental image I'm seeing when I'm doing real analysis, why we're doing it, etc., etc. What we're doing in real analysis, step one, thingify the reals. So up until now, if you haven't seen real analysis, you're probably just taking the reals for an intuitive idea of just the real numbers, like the number line, which is totally fine and usually is okay. Even in the stuff that we're doing later, it's still usually okay, but there's a few things we really want a rigorous basis for it. And so we thingify the reals. We say, okay, if the real numbers are a thing in and of them itself, what is that thing? How do we describe that thing? And at the time, historically speaking, when we were doing this, everything was turning out to be sets. So this is like 1870s, 80s, 90s, 1900s. And math was kind of, mathematicians were discovering that you could base everything on sets. And so they took everything. When they were analyzing something, you have to keep going down. If you have some object and you say, let's analyze this object to see what it's made of. That's the process of analysis. Synthesis is the opposite, is when you put it back together. Analysis is when you chunk it up. So they started chunking up things because they wanted to form a more rigorous basis for the different fields that they were doing at the time. And a lot of these fields were really, really advanced at that point, but they didn't really have that rigorous basis, which there's kind of two sides to that argument because you can do a lot of good math without like a fully rigorous base, and at the end of the day you have to accept axioms based on nothing but just acceptance. So there's two schools of thought. But anyway, at the time, they would drill down, and you drill down, but how do you know how far to drill down? At some point you have to stop. Like, you can just keep drilling down, and then what is the rules? And so basically the rules at the time were you drill down, and our bedrock is sets. So if you put everything in terms of sets, then you're good to go. And that's like set theory and all this stuff, but basically it's kind of cool and non-trivial in discovering that all of math, most of it, can be described in terms of sets. Everything's just like a set, and you make sets of sets, and it gets all really hairy, but like once you can describe a thing you're analyzing in terms of a set and some properties of sets and whatnot, then you're good to go. So set, properties of sets, that's golden. You can stop there. That's kind of the rules of the game. So our motivation is that, drilling down. We're drilling down to the real numbers, thingifying it. How do we put this in terms of sets? Secondly, it's a lot easier to have proving stuff. We discovered that it's really easy to prove things when you have a firm basis to draw on. So you want to prove this thing up here. You want to be able to draw on these particular properties, and to do that you need these properties. So when the reals were an intuitive concept, you kind of have to draw stuff out of thin air. You'd be like, well, the reals, between two reals there's probably going to be a real number because it's just a vibe, and you can kind of just keep make a real number wherever. But then it's like, let's make this rigorous and see if we can just have like a list of properties that then we can then draw on when we're proving things. That actually turned out to be very helpful because now we have like a rigorous basis. So it's like, this is what we can and cannot say about the reals. But that's kind of annoying if you haven't gotten up to that level yet. Which brings me to the prereqs for real analysis, abstract algebra. Controversial take, I know. Some people would say you don't need abstract algebra to learn real analysis. I'm going to go ahead and disagree. Abstract algebra is where we put things in terms of sets, properties of sets. That's like the whole thing of abstract algebra. You have a set of things, you see how they relate to each other. Basically, we're looking at the reals as if they're just a set of things and how they relate to each other and what those things are. So that's what we're looking at. We're saying our framework is sets and properties of sets. That's like the abstraction we're aiming for. How do we make this thing into our abstraction? That's actually like a lot of modern math too. It's in terms of sets. So if you ever get in struggle, just like sets, dude. Once you're in the cult of sets though, it becomes nice. Like working with sets is pretty chill. Like the language is nice, but before you get there, it's really, really frustrating, and the path is totally unclear. So abstract algebra, I don't really have any good books to recommend for that at the moment, but I'm going to sift through a bunch of other ones. But I had a hard time with abstract algebra. And then also calculus, you need a lot of experience with functions to understand why you're even doing this. You're analyzing the real number line. You're basically taking the real number line and you're saying, okay, I know this is intuitive, like you never pick up your pencil, you draw a continuous line. Okay, but let's really dive into this. Let's see exactly what this thing is in terms of rigorous, non just visual, non-intuitionistic standpoint, but like literal thing. So that's what you're doing. And also when you're doing real analysis, just always keep in mind the number line, because that's what you're analyzing, the number line, continuous number line, and that's what we're trying to describe in rigorous terms. It's the idea of continuity, rigor. That's the intuitive process that we're trying to make literal, which is really good for mind too. If you read The Master and His Emissary, I always show this book, but phenomenal book, and that's how you learn. You start with intuition, then you map it over to literal, and it's literally a brain structure that does that. It's like how we all operate. And then the third thing, logic. I'm right now diving into more rigorous logic, but there's kind of two levels of logic. There's like nice logic, like introduction to proofs and stuff, and then there's like way up there, And the way up there stuff is like grad school kind of level, where it's just heavy to the pin from the get-go. And I think there is like well, you can kind of get to this stuff, but with language down here, like it doesn't really require much stuff. It kind of assumes a lot of mathematical maturity and doesn't really need to. Anyway, for this level of logic, I'd recommend Book of Proof by Richard Hammock. If you haven't proven anything before, it's going to be almost impossible to do real analysis. They basically take different proof methods like contrapositive, contradiction, inductive proofs kind of for granted. So you really gotta have some sauce and proofs already. And Book of Proof by Richard Hammock, it's free. It's the first thing I learned on 17 about proofs, and it's a phenomenal book. It made me actually like proving stuff. It's great. And it goes through like even odd proofs. It's lovely. I don't want to spoil it for you. Great book. Just to summarize, if you want motivation for it, another angle is all these fields were built up in like the 1850s on the real numbers. So calculus, analysis, harmonic analysis, probably, I don't even know if topology existed, but all these different fields were based on the real numbers. And the problem was those were not rigorously defined. It's just like the reals, and everyone kind of knows what it is, and you probably know what it is. It's just like an infinite decimal. That's actually a pretty good way of thinking of it always, but it doesn't actually quite do it apparently. The reals as just basically any infinite decimal. That's pretty much it, but you needed to make that literal in terms of sets, and we decided that sets are going to be our basis. We can't have these intuitive concepts anymore. Drill down, have sets, then that counts as rigor, and that's just kind of an arbitrary thing that we've made up, but that's what we're doing. It's freaking sets, man. So in conclusion, if you're confused about what real analysis is, analysis of the reals, and then once we do that, then you do analysis of the functions from the reals, etc., but we're just taking the real numbers, we're thingifying them, and we're looking at them as a thing, describing that thing. Anyway, I gotta go to bed. So take it easy. I love you, Godspeed, and I'll see you in the next one, which is going to be probably pretty quick. I'm starting to do almost daily posting now. And also I'm not going to say the name again because I'm going to have to bleep that out in the first part, but this is very high. We got a very mathy themed, nautical-esque vibe, all I'm going to say. But that's going to be revealed in the next video, I think. So stay tuned for that. Yeah. Peace.